This is just going to be a short little lecture. It's really only one slide long, and the next one will be longer. But this one is just about another major line of evidence we have that black holes exist. And that is the fact that we have found supermassive black holes in the center of galaxies. By supermassive, I mean millions or even billions of times the mass of the sun. The black holes that we've been talking about so far that sort of form from the remnants of dead stars may have masses as big as, 100 or 150 times the mass of the sun. But most of them are a few times the mass of the sun, not very much. Here we're talking about ones that are millions or billions of times the mass of the sun. And of course, when we're talking about this, when we want to think about the center of galaxies, we'll probably sort of start with our own galaxy, the Milky Way. And the pictures on this slide are all of different kinds of things within the center of the Milky Way that are used to find a black hole there. And of course, just like with any black hole that we're searching for, we look for the stuff that's falling in. So this is a picture from your book, and it's sort of a zooming in on the center of the galaxy. So this is sort of 200 light years across, and this is in infrared. There's this thing down in the middle that's got a lot of infrared light there. Okay, now we zoom in 4 times, and so this is now 50 light years across. And this is now a radio image. And you can see these filaments of gas. And there's something interesting still going on down in this bright spot. So we zoom in again about 7 times on the bright spot. So this is 10 light years across. And you can see, okay, there's stuff that's really swirling around down into the middle. This is another radio picture. And there's something really, really bright down there. We zoom in yet again. And now this is 1 light year across. This kind of distance is only 1 light year across. This is an infrared picture. So, the center of the galaxy, there are a lot of stars. When you think out where we live, there's 4 light years from us to the next star, Alpha Centauri. But here in the center of the galaxy, there's dozens and dozens of stars all within 1 light year of each other. And we can study these stars, and we see that they're moving around. They're moving around really fast, and they seem to be orbiting around something that these little white arrows are pointing at. They're orbiting around something there. Occasionally, that little spot gives off bursts of X-rays. So what's going on down here? There's something we can't see that's dark that is making these guys orbit really fast and that occasionally gives off X-rays. Well, of course, we can do the same kind of deal that we do with the X-ray binary stars. We can measure how long it takes one of these stars to orbit around this invisible thing down here. We can see how far away they are. That's a pretty easy measurement to make. Let's say we're talking about this one. That's an easy measurement to make. And we can calculate the mass of this little thing down here. When you calculate that mass, you get something that is 4 million times the mass of the sun. 4 million times the mass of the sun in a very, very small space. I mean, this is much less than a light year, so we're talking about something probably smaller than the solar system. It's not giving off any light. It's black down there. And it's got 4 million times the mass of the sun. Well, the only thing that could be dark and still have 4 million times the mass of the sun is a really big black hole. Where do the X-rays come from? Well, the X-rays come from when a star gets sucked into a black hole. When it crosses, or when it gets close to the Schwarzschild radius, it starts getting ripped apart. And that gas swirls down into the supermassive black hole really, 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 really fast. I mean, you're talking about something with 4 million times the mass of the sun. You're going to be orbiting ridiculously fast. And so when it's moving that fast, that gas gives off X-rays. So the X-rays that we see down here are like a star being ripped apart by a black hole. So we have very good evidence that there is a black hole 4 million times the mass of the sun at the center of the Milky Way. And ever since we discovered that, which was in the 1990s, the astronomers have been looking at other galaxies and looking down in the center of those. And every large galaxy that we look at, every time we look at a large galaxy, we seem to find a supermassive black hole. Some of them are kind of like ours, a few million times the mass of the sun, but there are some where the mass of the black hole is billions of times the mass of the sun. So 2 billion, or even I think the current record is something closer to 10 billion times the mass of the sun in the center of large galaxies. We don't know why this is the case. How does a black hole get to be that big? Not really sure how that happens. We're still in the process of discovering it, but we do now think that all large galaxies have a supermassive black hole at their center.